Hello everyone, my name is Surajit Ghosh and in this video I will discuss about a design parameter that is used in AISC 360 code, CB parameter. I'll cover how the value is calculated internally, what value to specify depending on different conditions, and how to auto-calculate the value using custom template file.
Input and use of this parameter in a model is a bit tricky. Also, there is a change in latest version related to this parameter value, which I think you should know before using AISC 36016 code. First, let's discuss about the basic of CB parameter. This refers to equation F11 of AISC 36016 code. CB is the lateral torsional buckling modification factor, which is calculated using the moment values at different locations of the unbraced segment. For a structure, for each member and every load case, the moment values at quarter and midpoints of the unbraced length is calculated along with the maximum moment value, and using those values, this CB factor is calculated. As this depends on the moment values, so for different loading, this CB value change. So in your model, if you add 100 primary and combination load cases, for each load case, this CB value might be different depending on the nature and magnitude of the loading. Now this CB value is used to calculate the nominal flexural strength for lateral torsional buckling. If you check the equation of lateral torsional buckling strength calculation for any section like double symmetric I or channel section or single symmetric section or HSS section, you will notice that this CB value is used to calculate the mean value, and calculated lateral torsional buckling strength value is directly proportional to the CB value. So if CB value increases, strength increases and vice versa. Now check the inputs of CB parameter in STAAD. There are basically two inputs. Either CB value can be specified as 0 or any other number. If CB is specified as 0, program calculates the modification factor value internally. Means, depending on the moment values at different desired location for each load case, the CB value is internally calculated and that value is used for the strength calculation. If non-zero CB value is specified, then that value is used for the strength calculation. So program does not calculate the factor and user specified value is used for the design. In all STAAD version before the latest update 4 version of STAAD.Pro Connect Edition, the default value of CB was 0, which means if you don't specify CB parameter, program internally calculates the factor for each load case, and that was used for the design. In latest version, the default value is modified to 1, which means now program considers the factor as 1 by default to calculate the lateral torsional buckling strength. Program no longer calculates the factor internally, and only if the CB value is provided as 0, then it is calculated. You can find this information mentioned in the revision history file. This is one of the major reasons for mismatch of design results between older STAAD version with the latest update 4 version. If you create a model in older version of STAAD with default value of CB, which is 0, program internally calculates the factor, which normally comes greater than 1. Now, same file if you run in latest version, program uses the factor as 1, which is less than the previously calculated value, and hence capacity value reduces, which eventually increase the bending and interaction ratio values. So if you compare the results, you can find that older version reports the unity ratio value less than the ratio reported in the latest version. If you specify CB0 parameter and run the file in the latest version, then you can notice that the ratio values are identical. Obviously, depending on which older version you are using, if there is any other fix or not which can affect the design results. Now, why is this change and what is the correct value to be used for design? To answer this, let's talk about the importance of CB parameter in a model. This is a part of an industrial building structure, and I want to use this model to discuss about the CB parameter. For AISC code, STAAD performs the design for analytical member only. Physical member modeling in Connect Edition is limited to modeling and analysis for now and does not get carried over to the design phase yet. So for each segmented member, design is performed considering each member as a separate entity. If you want more information about physical and analytical member, you can go through my previous webinar on physical object modeling in STAAD.Pro Connect Edition. Consider these beam members connected between two column members. There is another beam connected at some intermediate node for which this member is divided in two parts to provide proper connectivity. Now the secondary member provides restraint to lateral movement, and hence the unbraced length for lateral torsional buckling reduces to the distance between the column and the secondary member. For this case, the actual analytical member length is equal to the unbraced length, and if you specify CB as 0, program calculates the CB factor based on the moment values for each member. And that is correct. Same for this member or this column. So if the member length is equal to the unbraced length, you can use CB value as 0. This produces more accurate results. Now consider these members. The member between the columns are divided in 3 segments, and there are no connecting member at intermediate location. So there is no restraint to top or bottom flange, and hence the unbraced length should be the total length between the columns. But if you assign the CV value as 0, program will consider the unbraced length as the member length, and on basis of the moment values at different location of individual member, this CV factor is calculated. As the unbraced length is not equal to the member length, this causes some problem. Consider any load case and check the moment diagram of these 3 members. Moment value at quarter and midpoints for whole member does not equal to the same moment value for individual member. Same is for the maximum moment value, which is different. That means during CV factor calculation, program is considering the moment value different from the original value, and hence CV factor is incorrectly calculated. This is why if the unbraced length does not match with the member length, CV value should not be specified as 0 or auto-calculate the CV factor. That's why the default value is modified to 1, which is more conservative. The actual value is greater than 1, and specifying the factor as 1 reduces the capacity value, which is in conservative side. Now, if you want to calculate actual CV factor for these segmented members, you can consider the actual moment diagram for the whole member and find out the moment values at desired location. I have created a macro which can extract the moment values for a physical member, and using these moments can calculate the CV factor. I have already created a physical member with these 3 segmented members, and say for load case 1, I want to check the overall CV factor. I can simply click on this tab, and CV factor is calculated both for the segmented members and physical member. You can notice how the CV factor varies if we consider the overall member. It is almost double for member 103 and 124. If you compare the results with the output file, you can notice that the CV factor for individual member match with my Excel, and also this value is used for the member design, not the actual CV factor. So the lateral torsional buckling strength is underestimated for some of the members. As we can't provide CV factor for individual load case as an input, this factor can be calculated for all the load cases, and minimum of these values can be specified as the CV parameter for the member design. This will increase the capacity value rather than specifying the CV parameter as 1. Also note that unlike other design parameters, CV parameter value is reset to default if you specify a new design block. It is not carry forwarded to the next design block. So always specify the CV parameter in each design block, else in the next block if you don't specify the CV parameter, program will use the default value, which is 1.
I hope this helps. Thanks for watching.